So, hello everyone. In this video, we're going to talk about the properties of summations. So, the first property of the summation is this. We have, let's say, a summation from k equals m to n of a sub k plus b sub k. So, if we have this terms a sub k plus b sub k, we can substitute to the summation into the individual terms. So then it will be equal to the summation of k equals m to n of a sub k plus the summation of k equals m to n of b sub k, wherein these terms a sub k and b sub k are real numbers. Okay. Now, another property of the summation is, suppose we have a summation of k equals m to n of c times a sub k, where c is a constant, a real number. So what we can do is take the constant out of the summation, and so then we have the constant times the summation of k equals m times n times a sub k. Okay, so now we are just concerned with the summation of a sub k. So this simplifies the equation a lot. So in the previous form, what we do is to multiply the constant to each of the term a sub k. But right now, we just take the summation first and then multiply it to the constant, right? So another property is, suppose we have the summation of k equals a minus I to b minus I of k plus 1. So this is equivalent to the summation of k equals a to b times k. So what we do here is to simply shift the index of the summation from a minus I to b minus I to a to b. So we are simplifying we are also simplifying this summation. And this is very much readable, actually. Okay, so we have k equals a to b of k. Now we also have another, we have a summation of k equals a plus 1 to b plus I of k minus I. So this may also be simplified. So we have k equals a summation of k equals a to b of k, okay, where I is a natural number. So if you see a summation of this form, then you can simplify it into this form using this property, right? So what if we have the summation of k equals 1 to n of c? So of course, the expanded form of this will be c plus c until the nth position, right? So this is equivalent to n times c. So now let's have an example. So we have the summation of k equals 1 to 3 of 5k plus k squared. So we want to simplify this using the summation that we have discussed. So since we have these two terms, right? So we have the 5k and the k squared. So what we can do is to distribute the summation into individual terms. So then it will be equal to the summation of k equals 1 to 3 times the 5k of 5k plus the summation of k equals 1 to 3 of k squared. Now, we know that we can actually now substitute the k here. So we have 5 plus 10 plus 15. Okay, so we have k equals 1 to 3. That will be, if k is equal to 1, that will be 5 times 1. So 5. If k is equal to 2, that will be 2. 2. So 2 times 5, that will be 10. If k is equal to 3, so that will be 5 times 3, which will result to 15. Okay, so what about the second term? The second term is the square of each na term, right? So we also have the index from 1 to 3. So if k is equal to 1, that will be 1 squared. That will result to 1. If k is equal to 2, that will be 2 squared. That will be equal to 4. If k is equal to 3, that will be 3 squared, which will be equal to 9. So then this will result to 44. So here's another way of simplifying this summation, or evaluating actually. The better term is evaluating. So we have the same expression and we want to evaluate this. So again, this summation may be distributed to the individual terms of this expression 5k plus k squared. And now we can see that there is a constant na 5. So using the second property, we can take the constant out of the summation. So we will be having 5 times the summation of k equals 1 to 3 of k, and plus similar na second term. So then we have 5 times 1 plus 2 plus 3. Okay, so if k is equal to 1, so that this will be 1. K is equal to 2. If k is equal to 3, we simply substitute that here. And similarly, the second term will be the square of each term 1, 2, and 3. So this will result to similar na result. Now, let us try to evaluate this summation also. So we have 3 times the summation of k equals 1 to n of 2k minus 3 plus the summation of k equals 1 to n of 4 minus 5k. So how can we use the properties of the summation to simplify this? So first, first thing that we can do is to distribute, is to take out this summation from the two terms. Okay, so we are using here the first property. So this will be equivalent to the summation of k equals 1 to n times the 3 times the first term, 3 times 2k minus 1 plus 4 minus 5k. So if we distribute this summation to these factors, to these two factors, then this will result, or this will revert back to the original na formula. Okay, so now after taking out the summation or factoring out the summation, so we can now evaluate this. So this will result to k minus 5, which is much simpler compared to this original equation, right? So how did we arrive to k minus 5? So we have 6k minus 9 plus 4 minus 5k. So we have 6k minus 5k, that will result to k. And we have negative 9 plus 4, that will give us negative 5. So that's why we have k minus 5. So we have this more simplified equation. The sum of k equals 1 to n times k minus 5. So what can we do next? So what we can do next is to distribute the summation to the individual factors, the individual terms, I mean k and 5. So we have the sum of k equals 1 to n times k minus the sum of k equals 1 to n times 5. Right? So we then have the sum of k equals 1 to n times k minus 5n. Right? So actually this, we can end this here. So they are basically equivalent. So next, double summation.